The second law of thermodynamics. If a process occurs in a closed system, the entropy of the system increases for irreversible process and remains constant for reversible process. It never decreases. That means delta S is larger or equal zero. It's never smaller than zero. This is the second law of thermodynamics. Reversible process. Let's look at above isothermal expansion again, and they include reservoir as a part of the closed system. So this is a reservoir, this is just some gas. Well, we see to keep the temperature T of the gas constant during the isothermal expansion, heat Q must be transferred from the reservoir to the gas. That's Q is positive because the gas system absorbs the heat. And the entropy of the gas increases during the thermal process and during the free expansion. It's increased. We have calculated the entropy change for the gas in the isothermal process. Delta S equal to Q over T. On the other hand, the reservoir output the same amount of the heat Q to the gas. So for the reservoir, the heat is output, so it is negative for the reservoir. The entropy change of the reservoir is minus Q over T. And we put them together, the entropy change of the closed system, which for the system and the environment, is the sum of these two quantities, which is zero. Although entropy may decrease in part of the closed system, there will be always an equal or larger entropy increase in another part of the system, so that the entropy of the system as a whole never decreases. In the real world, almost all processes are irreversible to some extent because of friction, turbulence, and other factors. So the entropy of real closed systems undergoes real process always increases. Processes in which the system entropy remains constant are always idealization.